Good morning. Mr. Professor Dr. Dolphy Gilpin, as I continue with my chemical description here and analysis of the portable periodic table. I've put the elements with the atomic number, atomic weight, and electron configuration in a deck of form, a deck of cards rather, and this easily facilitate traveling. Now these are random choices here made, and I'm just giving description of random choices of elements. Okay, let me just give a story of chemistry here. In 1974, I took the GCE O-level chemistry with other subjects, 7, and I got some distinction in chemistry, mathematics, and geography, and additional mathematics. I was one digit short of a distinction. But what has happened from 1974 until now is that we notice that chemistry has not changed in terms of atomic number. The atomic number of elements are still the same, no changes. Atomic weight, still the same with some little changes sometimes due to modern ways of measuring things. More precision numbers, significant numbers in decimal points can be found, but not normally whole number differences. But for all things remaining equal, there's no changes, only some infinitesimal change in the atomic weight due to more precise ways of measuring the atomic weights of elements. And that's only for certain cases. So all things being equal, I scored a distinction then, I would have scored a distinction now, all things being equal. And then another little story of my chemistry is that I was found to have been intellectually and academically prepared for my chemistry in 1973, and they delayed me 1 year. I took it in 1974, but I was ready in 1973. Analogously, like athletes running for the Olympics, you could say that here you have an athlete that has peaked and is ready now to get his medal in the Olympics, but somehow, sometimes injury and things prevent you from running your race, and you're so frustrated that you have trained all year round to get this medal in the Olympics, and right at the point you're injured. But in my case, I wasn't injured. It was just due to policies, school policies. They didn't allow me to take my chemistry, and for which I would have certainly passed, and mathematics as well. So you find out that my life was delayed 1 year. When I was supposed to be doing 4-point maths, I was doing 2-point. When I was supposed to be doing additional maths, I was doing ordinary maths, things like that. My life was a setback up until this moment, and I didn't get any credit for 1973. In 1974, I was to find a second peak of form, and I scored some distinction in subjects and things like that. But all things equal, I would have done it the same today, all things being equal, distinctions. Okay, so I wish Cambridge has been such of an inspiration to me that even now, here in America, wherever I see the word Cambridge, I could be driving my car and I peep through the window and I see Cambridge on the side of a road. The first thing that is magnetized to my mind is the Cambridge, England Cambridge exam and all that I've studied for Cambridge. So it has a magnetization property, this Cambridge, and I liked it. I love it. Anyway, let's go on. That was just an aside. Okay, so we are here now with some elements and the atomic weights, numbers, and electron configuration in random choices. And so here we have now, for this one, TL, and I think this is thallium, There's a thulium and there's a thallium. TL, I believe, yeah. TL. And sometimes I don't put on these little things, TL, and then you might want to mix it up with titanium because the L look like a high. But the atomic number will differentiate there. 81 and 204.38. And here we have now the noble gas configuration, or electrons configuration, 4F14, 5D10, 6S2, and 6P1. Thallium. So we move on, and we have here a very popular one now, Hg. Hg. And everyone would know that Hg is mercury. Atomic number 80, atomic mass of 200.59. And electrons configuration now of Xe, 4F14, 5D10, 6S2. Our next choices here is At, element with symbol At, and this would be acetine, or acetine, atomic number 85, and atomic mass 210, and electrons configuration now of Xe, 4F14, 5D10, 6X2, and 6P5. So we have thallium, mercury, and acetine. Let's dig into our deck of cards, you know, with the elements. And some of these, let me pluck it out from the center here. And the first one pops up here is chromium. Cr 24 51.996. Well, I notice I don't have the atomic, the electrons configuration of some of these. That's chromium. And here's one that's in the lanthanoid series now. Europium, EU. Atomic number 63, 151.9. And at another time, we'll give you the electrons configuration. Next one is vanadium, symbol V, 50.942 atomic mass and 23 atomic number. Fluorine is the next one here. And this is one, let me put a little note. Anytime you're doing any courses and they give you an F, just remember you could switch around and say F stands for fluorine and study fluorine. You'll never fail. So all the F's you turn into fluorine. And there's a special chemistry called fluorine chemistry. And fluorine has been known to be a very reactive element, reacting with almost all the elements of the periodic table, with the exception of probably two noble gas that it doesn't react with. But it reacts with all 118 elements except for just about 2 or so elements. So you have a special chemistry called fluorine chemistry. So that is for the people who are given F in subjects. Don't feel embarrassed, but just say F. Oh, they gave me fluorine, and start studying fluorine. Okay. 9. 18.988. 18.998. And here we have electronics configuration of fluorine here for He, 2s2, 2p5. And that is a member of the halogen family, the halogen series, fluorine, bromine, chlorine, acetine, and so on. So fluorine, very interesting element there. Next one we have here, we see UNP. This is one of those modern things, 105, which is unyl pentium. Element 105 here. Let's write it here. UNP, unyl pentium. (105) atomic weight. And this is in the modern nomenclature of the element. Much more to be said on that. 105.